Hey everyone, hello and welcome. I'm super excited to be here today to talk about embarking on your security journey. For those of you that don't know me, my name is Seth and I work at Google. I'm an engineer at Google. I've been at Google for about 3.5 years now. And if you've ever seen me give a talk before, you know I love to do like live demos and interactive coding. And this isn't one of those talks. In fact, this is more of a story. But it's an interactive story, at least as interactive as we can be with everyone being all digital and at home. When I was coming up for the idea for this talk, I had a few different ideas for the title in mind. I thought about essentials of risk management, but that felt a little bit too pointed and I didn't want to attract the wrong audience. And then I thought about, well, what if we have secure code development? That's a very catchy title. But I think we all know that the most secure code is no code at all. And then finally, I thought about something a little bit pointed, like you're probably doing all of your security wrong, but I wanted to be a little bit less controversial. So we landed on embarking on your security journey. And the reason for that is it doesn't matter if you're a small startup with 1 or 2 employees or a large enterprise company with tens of thousands of employees. Security is a journey. There's no distinguished starting point or ending point. It's really a continuously evolving journey. So with that, jump in my time machine as we go back in time to the 1990s. Specifically, let's go back to 1998. In 1998, back when Dreamweaver was still owned by Macromedia, I was building websites. And let me tell you, it was visitor counters and marquee tags all day. And here's what was great. When I configured Dreamweaver so that I clicked save, it would automatically FTP my changes directly from my local machine into production. It wasn't even SFTP, just like straight FTP on port 22, good to go. There was no CI/CD, there was no code review, and honestly, who even needed source control when you have RAID 5 and Control Z? And I argue that this was honestly the best development experience that our industry has ever had. Sure, there's many drawbacks, but the idea that I could use my local IDE to save a file and have those changes immediately reflected in production, well, that's as far left as you can possibly shift. But unfortunately, with all good things, they must come to an end. They evolve over time. Because at some point, our little side project with marquee tags had to turn into a product, and our, small hobby site with a few thousand visitors a year had to turn into a business. So for this next trick on our journey, I'm going to need a willing volunteer from the audience. You have all volunteered because you're all digital and you don't have a choice. So introduce yourself to yourself. And what we're going to do here is we're going to do a little bit of an empathy building exercise. So I'm your narrator and I'm a developer, and you watching at home, you're our first hire as our security engineer. So you're our first key hire. You have a big background in security, and you need to secure our startup as we go to the moon. So I have this web application, and we're turning it into a business. And I would like you, sitting at home, to do a security review. Do you agree? If you don't agree, you're fired. So you agree. So let me just go ahead and get our code. So I have our code here. If you could just put your mailing address in the chat, I'll drop this in the post office today. It is encrypted, so you'll need to deal with that. But it's encrypted, so good security. And is there a problem here? I see. So the first thing that we need to talk about on your journey to a better secure solution is picking up all these pieces of paper and then using version control. Now, this might seem obvious, and I imagine that most companies today, being the year 2021, are already using version control. But you would be surprised the number of applications that aren't using proper version control, proper version controlling practices, or leveraging the security properties that come with using version control. Version control keeps track of all of your changes in some system in a central or decentralized way. It provides a single source of truth, but it also enables things like collaboration and auditability. If you're working in a compliant organization, you may need to prove that certain code is or is not running in production. And having version control allows you to have those attestations or those proofs that certain code is or is not running. So let's say we've solved this problem. We have version control, and now we can collaborate. And especially in this current remote world, it's really important. We're all in different time zones all across the world. Version control makes it easy for us to collaborate without needing to be in the same room. Now, you're not our first security engineering hire. I lied a little bit earlier. You're actually our second. We had a previous security engineer, and he just kept using all these buzzwords that I didn't understand. But he said we need to use the correct crypto. And to be honest, I didn't know what he was talking about. So before we hired you, I just went ahead and asked on Stack Overflow. So I got some really good answers. Most of the people said that I should use the blockchain. But this person gave me a really, really detailed response. They said, my security team has this policy, my question is, they have this policy, can someone please help? This person provided a really solid answer. Obviously, our application is written in Java and it processes credit cards, so we need to be really, really secure. And they've provided this really detailed answer, making sure we disable SSL revocation, making sure we're not using too much entropy in our keys because that'll be really slow, making sure we're using algorithms like DES and triple DES. And the best part about all of this is they were so humble, they didn't even credit their own work on their answer. Now, obviously, I made this up. This isn't a real question on Stack Overflow, and Anonymous hopefully doesn't answer questions. But my point is that this exaggerated example actually happens all of the time. Developers are constantly asking questions, and I was a Ruby developer for many years, and for a very long time, every answer on Stack Overflow, anytime a Ruby developer or Rails developer asked, I'm getting this error about SSL certificate failed to validate, the top answer was always just disable SSL certificate checking or CA checking. And that's a really bad practice. So what is the solution here? Well, if you're a company or an organization that cares about security, you have to make security easy and codified for your employees. If security is difficult, people are going to skip it or they're going to do it incorrectly. To put it another way, security teams need to provide frameworks and technologies that enable developers to color inside of the lines in the coloring book. Or to draw a third analogy, you need to invest in user interface, user experience, and developer experience to make security simple and flexible. Proper security is a lot like an automobile. Only mechanics need to understand the entire system. Drivers just need the steering wheel, the shifter, and the pedals, and maybe the radio. So in this example, the mechanics are the security engineers and the drivers are your engineers. Most engineers don't need to know all of the nuance with securing applications and infrastructure, but the security teams need to provide interfaces that make it easy for them to do that. Can you imagine if in order to drive a vehicle, we had to manually fire each piston? There would be so many accidents on the road. So let's say we've solved this problem. We've invested the engineering resources to build this amazing security framework and a supporting team that all our developers can use. We have version control. We're using all these new tools, all of the latest and greatest. We have about 35,000 lines of code in production. We need you to review them. And we're waiting. Like I said, we're trying to go to the moon. So if you could get this done as quickly as possible, I'd really appreciate it. Well, if you don't have time, could you just approve it? I promise it's good. And this brings us to our next point, which is we have to invest in automation in order to scale. You have to scale sublinearly with your developers. Humans make mistakes. We can reduce the rate and the cost of those mistakes by codifying our security best practices and reviews. This can include leveraging technologies like static analysis, vulnerability scanning, and fuzzing. To put this another way, best practices belong in code, not in corporate wikis. So let's say your developers send their code to the security team and you have a backlog because there's only 2 or 3 security engineers and there's 50 developers. So it takes about 2 weeks before we can actually get to that code review and run the security scanning and all of the automation tools that we just invested in. And that actual scan takes about 20 minutes to finish. But again, it's been 2 weeks since you've gotten the code. It finds 18 vulnerabilities, but worse, you've actually discovered a critical design flaw that reduces the security of the system, and it's going to require a significant refactor. Uh-oh. So you meet with the development team and you share the bad news. Remember, it's been almost 2.5 weeks since they've sent your code, and they're just hearing from you, and you're telling them that they need to re-architect their entire application. As a result, the project is delayed a year, and worse, the development team hates you. I firmly believe that security teams should not be viewed as a place where dreams go to die. It should really be a partnership. Legal is where dreams go to die. The security teams ultimately have your company's best interests at heart. So security teams need to participate early, and they need to participate often. Members of the security team need to be involved at a project or a new feature's onset. That includes things like system design, regular code reviews, deployments, and rollbacks. You can approve designs and run security software regularly for the team. This dramatically reduces the feedback loop, and it builds a partnership model. So not only are you learning about how the developers expect to secure their code, but you're helping developers learn security best practices and scaling non-linearly. So you might say, though, this works great for a small organization, but our startup is really taking off. Now we have over 150 software developers, but our security team is still only 5 people. How are you possibly going to support 150 developers doing all of the security review and one-on-one consulting? And we can't hire a new security engineer for each new project or each new customer that we onboard. And this brings us to our next part in our journey, which is that security engineering has to scale sublinearly with their stakeholders. Whether that's internal stakeholders or external customers, you have to scale sublinearly. At Google, a large part of our success is our ability to scale. Check out any of the information we published on site reliability engineering. And our security practice is honestly based on the same principles. We have to scale sublinearly. If every new customer that signed up for Gmail required a new security engineer to come onto staff, we would run out of security engineers and we would never be able to fund that project. We have to scale sublinearly. So just to recall is where we are in our current journey. Earlier, we invested in automating many of the processes and scans that were previously manual, but we still rely on someone from the security team to partner with the developers and execute those tools and report on the results. What we really need to do is we need to bring those security tools into our existing CI/CD pipeline so that our developers run their security tests or analysis at the same time they're running their unit tests or their functional tests. So let's say we have that all set up. It's actually not that hard. Instead of relying on the security team to kick off the scanning software, we just add it to our existing Jenkins or Circle or Travis or Cloud Build pipeline, and we're good to go. And now we've actually shifted left with security. We've given a lot of capability and analysis to our security or engineering team, and we've allowed our security team to scale because they don't need to be directly involved with every single review. They can focus on things at a higher level. So let's say we have that set up and it's working great. Everything's functioning, everyone is happy. But we have introduced a security vulnerability. Did anyone recognize it? Removing the security engineer from the loop also removed the verification that proper security checks were being followed. By shifting left and giving control to the developers, we've also given up control over the security practices. To put it another way, what stops the developers from just removing the security scanning from their CI pipeline? They can just comment out that code. The same might be true for their tests. What stops a development team from just deleting a test? I don't know about you, but I'm not ashamed to admit that in my career as a developer, I've deleted a test or two because it was flaky. That might not have been the best thing to do. And if security starts to slow down your developers and they have control over their CI/CD pipeline, they're just going to comment out those particular steps. And now you may have code that has CVEs or vulnerabilities running in production. So what can we do? Well, here's where we're kind of transitioning away from what's known to what's evolving and becoming practice in the industry. When we remove the human from the loop, teams began circumventing our security process. So we need to start investing in technology that enforces that those security scans have taken place while still allowing developers as much control over their CI and build pipelines as possible. So how are we going to do that? Well, the answer is cryptographic signatures and asymmetric cryptography. We need our security tooling to sign the application bundles, and then production, our production target, whether that's Kubernetes or on-premise or VMs, needs to check that those signatures exist. So what does this look like at a very high level? Well, let's say we have an asymmetric key pair. That means we have a private key and a public key. We give our security tools permission to use that private key. Whenever they run, assuming they pass or they pass with some threshold, they then sign the git SHA or the container or whatever the build artifact is for the code that they scanned using that private key. Then our production system uses the associated public key to verify that certain signatures exist on the code or the container or the virtual machine before it allows admission into production. By leveraging asymmetric cryptography, we can ensure that only the person who holds the private key, or in this case, the security suite that holds the private key, can provide these attestations or signatures. But then the public key is available and is not a secret for anything that runs those target workloads. So this is actually really, really great because it allows us to enforce the security attestations or any attestation, it doesn't have to be security, before our code can enter production. So let's forget about security for a moment. Let's say your quality assurance department is really struggling. They keep filing bugs and saying, hey, this button, you can't actually click on it, or this thing is off by 1 pixel, and the developers aren't listening. They're just deploying the code anyway. You can add an attestation that QA must sign off on a build before it can go to production. Today, you might be doing this with a ticketing system like Jira, but you could actually do this with cryptographic signatures and enforce this at the production layer. So only members of the quality assurance team have the ability to sign code or a binary to run in production. Thus, we can say that a build has to have a QA signature in order to run, and we can force security review or quality assurance review or even legal review following the same process. There's a number of open source tools and technologies like Kritis that will do this for you if you're running on, say, Kubernetes. We also have things on Google Cloud like binary authorization that kind of do this as a service. But ultimately, it's just asymmetric cryptography and leveraging signatures on something like a version control hash in Git or a container SHA-256 from a Docker registry. But there's still an escape hatch. There's still a way to escape from prison. So you might have been thinking to yourself, well, what happens if it's the middle of the night and we have a production outage and I need to deploy some code? I can't possibly wake up my legal team, my QA team, my security team just to get these attestations on my code. Well, that's okay. There are situations where you may legitimately want to skip those reviews, particularly during a production incident. In those cases, there's always an escape hatch. The key is that that escape hatch sets off a number of auditing and logging events. For example, internally at Google, we have a very similar system to the one that I described. And if a developer bypasses these controls, they can deploy code to production, but it also alerts their VP and their SVP via an email in the morning. So if there was a legitimate business case to perform this action, not a problem. But if someone's circumventing controls and they're not authorized to do so, obviously there's going to be repercussions. And this is a good point to mention that security isn't all about prevention. You always have to invest and save resources for detection and auditing and response. And these cryptographic signatures are a really good example of 99% of the time we want everything to go through the pipeline, but there's always exceptions to the security reviews. And that leads really nicely into one of my last points, which is that security isn't binary. Sure, under the hood, it's all ones and zeros, but checklists, frameworks, and automation only help us. We always need to remember that there's humans in the loop, and we can't forget that human element. There are going to be exceptions to rules, and disagreements are going to happen. Teams are going to have requirements that exist outside of the security specification, and honestly, security specifications are constantly evolving. 5 years ago, I assure you that no one included CPU level vulnerabilities in their threat models. But today, you can't read a threat model without one. So it's constantly evolving and it's constantly a moving target, and we can't be afraid to have conversations. Developers need to be willing to compromise their engineering velocity to improve security, and security teams need to be willing to meet and potentially rethink some of their security requirements to unblock developers and ultimately make customers successful. Security is a moving target. You always have to be evolving and moving. Things are going to break, and this is why dedicated security teams exist. To put it another way, you're never done. And that's actually good, because if security had a start and a stop, then most of us would be out of a job. And this is why the title of this talk is Embarking on Your Journey, not embarking on your finish or not crossing the finish line, because that target is always moving. I'd like to end today with a pretty fun story. My last point is that we have to embrace mistakes as learning opportunities. And this is fundamentally part of many cultures, including the engineering culture at Google. So I'm going to tell a story that we've talked about publicly, and we've even had it in a couple white papers. But if this is your first time hearing it, I hope it's exciting. Internally at Google, we have a password manager. It holds various passwords that need to be shared among teams, could be API keys, etc. And one time we had an outage, right? Outages happen, the system crashed. Now, the system was multi-tenant, and all of the kind of encryption happens in memory, so nothing's ever persisted to disk in plain text, because that's the security model of the system. And because every single instance went down, all of the memory was expunged, and now the encryption keys were gone. And that's okay, because we had planned for this when designing the system. Even though the data is encrypted, the recovery key to restore that encrypted data was locked into a safe, printed on a physical piece of paper and put into a physical safe with a physical lock. And the idea was that in the event that the system ever went down, the people responsible for the system would get paged. They would go physically visit the safe. They would put the combination into the safe. They would get the piece of paper out. They would type in a very long string, and the system would be back online. But there was one problem. The combination for the safe was actually stored inside this password manager. So a little bit of a circular dependency. So how do you get the password for the safe out of the password manager that you need something from inside of the safe? Well, like a good game of rock, paper, scissors, encryption key beats safe, but crowbar also beats safe. So long story short, we had a backup plan. We thought we had a really good backup plan. It all sounded great on paper, but the backup plan wasn't tested, and the crowbar did win. My point in telling this story is that even the best security practices and even the organizations that we like to hold on a pedestal for practicing good security make mistakes, right? Even Google makes mistakes. We've talked about this incident publicly. It's a really fun story about how a circular dependency can cause hours and hours of unavailability. The point is that there's absolutely no substitute for good practice. And this bleeds a little bit into like DevOps and SRE, but at Google, we believe that an untested backup plan isn't a plan at all. And we should regularly and intentionally be breaking systems and testing their security. In fact, we've published a number of white papers about this. We regularly break systems as part of routine testing to verify that they fail in the expected way, because an untested backup isn't a backup. You can read more about this in any of the documentation or white papers that we've published. But this extends to security too. If you're not regularly testing your incident response, how do you know it's going to succeed? If you have the ability to page and escalate, and you haven't tested that process in a while, how do you know that the phone numbers and that people still have their apps installed properly? We need to be thinking about security the same way we think about reliability, because there's actually a lot of parallels, and there's a lot we can learn in doing so. So to summarize everything, at the beginning of this talk, I said this was a journey, and hopefully I emphasized that there is no start and there is no stop. If there's one thing that you have to leave this talk with, know that security is not a checkbox. Security is a journey that encompasses multiple teams, multiple technologies, and multiple paradigms. It's an ever-moving target, and it's never done. Thank you all so much. I'd love to take some questions and chat a little bit more about this.
Well, thank you so much for that. Super, super appreciate it. As always, super, super interesting, very compelling. Give me a thumbs up there, Seth, if you can hear me this time around.
I can hear you this time around.
Fantastic. I'm happy to hear it. So we do have some questions coming in from the audience. Those of you in the audience, the Q&A panel is beside the chat tab in the chat feature of the virtual stage, and some of you have already discovered it. So by far the most upvoted question is, hello, Seth. Hi. Can you advise some security checking tools for use in CI/CD pipeline in the Python universe?
Well, geez, I'm not a Python developer. I'm actually a Ruby or a Go developer. I'd be happy to do some investigation and get back to you, but there's kind of 3 layers that you can check at. So you can check at the code layer, which is going to be some Python specific thing. If you're Googling, check for things with keywords like static analyzer or static security analyzer. There's also going to be more dynamic things like penetration testing. But again, I'm not super familiar with that ecosystem. One layer above that, though, you have your package of that Python application. So are you deploying in a container? Are you deploying in a VM? And there's a number of security tools that exist at those layers, right? You have tools like Aqua, you have tools like proprietary cloud software. You can spend anywhere from $0 to $1 million on some of those technologies, depending on your scale and your usage, right? And then there's the runtime layer, which is more of an active scan, things like endpoint protection, WAF, SQL injection, right? Which might be provided by like a physical hardware appliance, like a Barracuda, or like a cloud provider WAF, or a CDN WAF, web application firewall, WAF.
Excellent. Thank you. Appreciate that. Another excellent question. Are there any security organizational topologies out there, like the DevOps topologies, for example?
Yeah, that's actually a great question. I will present this as my opinion, not the opinion of Google. But what I've seen work really well is that security teams have to report through a different structure that ultimately doesn't put them at odds with engineering. So it's actually the same problem with like kind of the DevOps and SRE reporting structure, which is that if the SREs report to the same people who are responsible for delivering features, the features will always win. And the same is true for security, right? If security ultimately reports to people who are responsible for delivering functionality, that functionality will win over security. So you really need a separate reporting structure. Ideally, you need a VP of like reliability and security because they are closely related. And I don't think I'm opposed to having like SRE and security all report up through, eventually the same SVP.
All right, fair enough. So just actually to think about that a little further, if they're not reporting up through the same structure, what does that oversight end up looking like ultimately?
So it ends up being kind of a shared responsibility model where you could either have kind of the security team as a service where if you're a development team and you want security review, you file a ticket and you get put in some queue. Or it can be a little bit more of a partnership model where you have like a pool of people who specialize in a certain area and they rotate throughout, or they're assigned to like a number of development teams that they regularly collaborate with. So that's really what kind of culture you want to build. But then ultimately the incentive structure has to be one such that the security teams are rewarded for providing the advice and making sure that the advice is heard. But then the development teams themselves are ultimately responsible for implementing it. So we can't penalize the security team if a development team says, no, we're just not going to do that. We have to make sure that developers are properly incentivized to follow the advice, but we also have to make sure that we're not putting too much pressure on the security teams because ultimately they can't write every line of code that hits production. And if we're trying to scale, they can't even review every line of code that hits production. They really need to focus on the critical pieces and rely on automation to kind of pick up the rest.
So really identifying those critical pathways, concentrating on those, and then inculcating a culture of safety and security practice, ultimately.
Right. And helping developers understand that like security is everyone's responsibility. And, at the organizational level, you don't need a PhD in cryptography in order to write secure code because there's tools and libraries and plugins that make it really easy. So let's take a really concrete example. Let's say my app needs to do encryption and decryption. There's like a million ways to do that. And like, that's just in Ruby, right? There's another million in Python. So how do I know what ciphers to use? How do I know what block size to use? Like, I should not need a PhD in cryptography to write that code. The security engineering team ultimately understands the policies in the industry and the regulation, so they know what cipher suites are and are not allowed. So instead of saying, oh yeah, just go do cryptography, they should produce like a Ruby gem or a Go package internally to the organization that says, this is how we do encryption and decryption. All you do is take a dependency on this, we maintain it as a security engineering team, and if you use that, you check these boxes.
Excellent. Well, we've got time for one more. Hi, Seth. Could you recommend some security courses or potentially other materials to help improve from basics to actual best practices?
So there's a number of courses on Coursera. Those are paid, but you can usually find like free credits and boot camps. You'll need to decide what areas of security you want to focus on, right? There's things like infrastructure security, where you're thinking about things kind of at the cloud layer or even the physical layer if you're on premise. There's application security, there's web security. My recommendation, if you're trying to figure out where to get started, is just go read everything from OWASP, because web application security is such a broad field. You can always find something that's interesting, and most of that's actually open source. And available, on GitHub or on stuff licensed under Apache.
Yeah, you're right. I mean, OWASP is probably your best bet once you're looking for actual, boots on the ground type analysis of things, right? And as you said, it's a potpourri. There's going to be something in there for everybody. Last question, because we got a little bit more time, because I already did the contest thing. Do you have something like planned security drills for employees at Google? Or if you're not allowed to talk about that, would you recommend something like planned security drills within a security conscious organization?
Definitely recommend it. We don't have planned security drills specifically. We have a project that we've talked about externally called DIRT, which is, disaster and recovery testing, I believe, DIRT. That white paper that I had a screenshot of actually goes into detail about this, but security is one of the things that we test in there. So we've done things like simulated an earthquake in Mountain View, where we actually disconnected the cell phone service of everyone in the Mountain View office on their Google phones. And it turns out that identified some flaws in our escalation procedures that were then fixed later. And it also spread out our leadership among a number of different offices. Things like that you don't think about. But security is included as part of that, but I wouldn't say we have security specific drills.
Excellent. Thank you very much for your talk and for your candid answers. That's all the time we have with Seth today. Hopefully he can maybe join us in the chat, join us in the open space a little later. We'll see what happens. So a big round of virtual applause for Seth. Thank you so much.
Yeah, thanks, Dan. Thanks for having me, and thanks to all the organizers for making this happen.